This is sample problem 3. Please copy down this question. A cast iron cylinder has external and internal millimeters and 70 millimeters diameter respectively. Compute the total axial contraction and the normal stress when the load with a force of 80 kilonewtons for a length of 100 millimeters, where the Young modulus, which is E for cast iron, is 200 times 10 raised to the power 9 Newton per meter square. Copy down this question.
From that, we have our given parameters here on the board. So we have this as 0.09 meters. We also have this as 0.07 meters. We have this as 8 times 10 to the power 4 Newton. We have this as 0.1 meters. Of course, these are things you should play with. My emphasis on this. Play with this is very, very important. So let's say calculate first of all. Try to calculate the extension, which is more of like the contraction, total contraction. I'll calculate the stress. Okay, now first of all, we know that we can either do it two ways. The area of this, I told you in our last video, is this square, du square dy I square. That is the external minus the internal, the square of the external and internal. So we're having this as 3.142 over 4 bracket. We're having this as 0.09 square, 0.07 square. So this will give you a value. This will give us a 3 times 10 raised to the power -3 meters square. So it's very, very important to take note of this. So first of all, let's calculate the extension first. So first of all, we have to calculate the total contraction, the total axial contraction. So we have this given as P L over A E. So we have this as we have our load as 8 times 10 raised to the power 4. Multiply the length. We have our length as 0.1 meters. 0.1 meters. All over, we have our area as 3 times 10 raised to the power -3. Multiplied by our modulus, which is 200 times 10 raised to the power 9. So we have our extension or total axial contraction to be given us 1.3335 times 10 raised to the power -5 meters. So this is the value of the total axial contraction. So next we are looking for what? The nominal stress. Of course, we know that stress is given by the load over the area. We have our load to be 8 times 10 raised to the power 4 over, we had our area here to be 3 times 10 raised to the power -3. So we have this as 3 times 10 raised to the power -3. So when we do arithmetic here, we'll have our stress to be 26.7 times 10 raised to the power 6 Newton per meter square. So we can therefore give our stress as 26.7. 10 raised to the power 3 is what? Mega Newton per meter square. Very, very important. So this is the value for the nominal stress, and this is the value for the total axial contraction.